Welcome to the Deep Dive. Today we're heading out into the cosmos, looking at a really fascinating new discovery.
Yeah, it's about an exoplanet found orbiting a white dwarf star, basically, a dead star.
Right, but this isn't just any old exoplanet finding. This one is different.
It really is. It's actually the coldest planet they've ever found around a white dwarf. And that discovery is, well, it's making scientists rethink quite a bit about how planets can even survive their star's death.
Exactly. It challenges those long-held ideas. The findings come from an international team, and they use the James Webb Space Telescope, JWST.
That incredible instrument, yeah.
So our mission today in this deep dive is to unpack why this icy world is such a big deal, how they actually spotted it, and, what it suggests about how planetary systems evolve, especially at the very end.
Sounds good. Let's get into it. So the planet's designation is WD 1856 plus 534b, quite a mouthful. Huh, yeah. It was actually first noticed back in 2020. But it's the follow-up, the detailed look with JWST, specifically using its mid-infrared instrument MERI, that gave us the real breakthrough info.
And the big headline from that MRI data is the temperature,
right? Absolutely. It's incredibly cold. We're talking minus 125 degrees Fahrenheit. That's minus 87 Celsius. Just frigid.
Wow. Minus 125 F. How does that compare to, the previous coldest?
Oh, it blows it out of the water. The previous record holder, Epsilon Indiab, was around 35 degrees Fahrenheit, so maybe 2 Celsius. Almost balmy in comparison.
Okay, huge difference then.
Massive. And what's really significant here, beyond just setting a record, is getting below that 200 Kelvin threshold. See, planets this cold emit infrared light differently.
So it's about how we detect them.
Exactly. JWST's MRI is tuned perfectly for this. It means we might now be able to directly detect gas giants that are much more like, say, Jupiter or Saturn in temperature, even if they're orbiting other stars. It's like we finally have the right tool for the job.
So it's not just a cold curiosity. It actually opens up new possibilities for finding other worlds.
Okay. Now let's talk about this location. The Forbidden Zone. It sounds dramatic. It does, doesn't it? Well, first, remember what a white dwarf is. It's the leftover core of a star, like our sun, after it's run out of fuel and puffed off its outer layers. Super dense.
Right, the stellar remnant.
Yeah. Now, the Forbidden Zone is the area really close around that white dwarf. The standard thinking was that when the original star swelled up into a red giant, that's the phase before it becomes a white dwarf, anything orbiting that close would just get swallowed, vaporized, gone.
So planets weren't supposed to be there, period.
Pretty much. It was considered, forbidden territory for intact planets. But WD 1856 plus 534b is sitting right there.
And it's intact.
Apparently so. It's the first confirmed case of an intact planet found smack bang in this zone. This is direct proof that planets can somehow end up in these tight orbits around white dwarfs after the star has died.
That's incredible. So it didn't get swallowed?
It seems not. And it even raises the possibility, maybe down the line, that planets could migrate into what might be a habitable zone around a white dwarf.
A habitable zone around a dead star. That's a wild thought.
It completely shifts perspectives, doesn't it? Thinking about where life might potentially exist.
Absolutely mind-blowing.
Yep.
So, okay, what else do we know about this survivor planet itself?
Well, classification-wise, it's a gas giant. Think Jupiter, Saturn. It's about 81 light years away, which is, relatively close in cosmic terms.
81 light years, okay.
And its orbit is really fast. It whips around that white dwarf every 1.4 Earth days.
Wow, a year? That's less than a day and a half.
Crazy, right? And its mass isn't too extreme. They estimate no more than about 6 times Jupiter's mass.
6 Jupiter's max, okay. But the big question remains, how did it survive the red giant phase? And how did it get into that forbidden zone?
That's the million-dollar question, really. Its survival through that violent stellar death is surprising in itself. The leading theory now is migration.
Migration? So it wasn't always that close?
Almost certainly not. The idea is it formed much, much farther out in the system. Then later, maybe due to gravitational kicks from other planets or interactions with leftover debris, it got nudged inwards. It spiraled closer over time.
Like a game of cosmic pinball or something.
Kind of, yeah. A complex gravitational dance after the star itself had already, gone through its major death throes.
So it dodged the red giant inferno and then got flung inwards later on.
That seems to be the most plausible story. Mary Ann Limbach, she's the astronomer who led this study, she mentioned how surprised they were.
Oh, yeah. What did she say?
She said, a bit surprised and excited to find that it was, in fact, a planet, and a really cold one at that. She stressed that the findings give compelling evidence for this idea of survival and migration.
Compelling evidence. That really highlights how unexpected this is. If we thought this zone was always cleared out, does this planet's survival mean our models of the red giant phase are maybe incomplete? Or maybe there are different ways planets get engulfed?
That's exactly the kind of question this discovery raises. It pushes the theorists back to the drawing board in some ways. And yeah, it definitely fuels the desire to look at more white dwarfs with JWST.
So what's next? Point JWST at more of these systems.
Absolutely. The team hopes to use Webb to try and directly image even colder gas giants, maybe closer in, maybe down to temperatures like 75 Kelvin. That's incredibly cold, like the outer planets in our solar system.
Getting down to Neptune or Uranus temperatures, basically.
Yeah, exactly. Imagine being able to study the atmospheres and the heat properties of planets that cold orbiting other stars, especially dead stars. It tells us so much about the extremes planetary systems can endure.
It really sounds like we're just scratching the surface of a whole population of planets we didn't even really know could exist in these environments.
It feels that way. It's super exciting. Exploring these cold worlds will give us, invaluable data about how diverse planets are and the processes that shape them, even long after their star has faded.
Okay, so let's try and sum this up. We've got this record-breakingly cold exoplanet, WD 1856 plus 534b, orbiting a white dwarf.
Right inside the so-called forbidden zone.
Which totally challenges our old ideas about planets getting destroyed when their star dies. It seems to have survived and then migrated inwards.
And that survival and migration part is key. It shows planetary systems can keep evolving in dramatic ways even after the main star is, for all intents and purposes, gone.
It really makes you think about our own solar system's future, doesn't it? Billions of years from now, when our sun becomes a white dwarf, could Jupiter or Saturn migrate inwards like this?
It's a fascinating thought experiment. This discovery certainly adds weight to the idea that migration is a really powerful force, shaping systems right to the very end. Finding this planet here opens up whole new possibilities for where planets might end up.
Yeah. This deep dive has definitely broadened my cosmic view. It really leaves you wondering, what other kinds of weird and wonderful planetary arrangements are hiding out there around these stellar remnants?
Exactly. Things we haven't even conceived of yet.
And what can finding these cold surviving worlds ultimately teach us about the fate of planetary systems everywhere, maybe even our own eventually? Lots to think about. Thanks for digging into this with me.
My pleasure. It's a truly remarkable discovery.